Hello, hello, hello. 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 আসছে তো। এটা 15টা। Hello, hello. One point 146 হলো। Hello. Hello, hello, hello. Mic ଉଠଉଛି। Green dot. Hello, hello. ହଁ ଉଠଉଛି। ଠିକ ଅଛି।
এটা আছে জানি Good morning, everyone. My name is Rajasmita Kar, and today I'm going to present about bio-inspired real-time facial emotion detection using Yellow 11. This is my presentation outline page. Yes, sir. You are from which college? Odisha University of Technology and Research. Yes, sir. Facial emotion recognition is a technology that analyzes facial expression from images and from videos, and to determine the emotional state. Determine emotional state. Uh, who- Facial emotion detection plays a pivotal role in enhancing human-computer interaction by enabling system to interpret, and respond to users' emotional state. This capability fosters more intuitive, efficient, and personalized interaction. Then, by detecting the emotions in real time, um, facial emotion recognition enable AI-driven application for which adapt response and create natural and engaging user experience. But then next, coming to next, what is bio-inspired image processing? Bio-inspired image processing is a field that use biological system, particularly human visual system to develop algorithms and techniques for image analysis and aiming to mimic or replicate the human visual capabilities. This is my literature survey page. I have taken number of papers for my literature survey, from which first one was published by Ajrani and all, which was published on 2024. And here are the techniques are used at deep learning, equilibrium optimization, and artificial intelligence. Here the research gap is inspection of proposed technique on large scale real time data set. Second one was published by Jaham and all, which was published on 2024. And here are the here the technique is used yellow V11. Yellow V11 outperformed predecessors in accuracy, speed, and computational efficiency. Third one was published by Ismail on 2024, and here as the technique are used yellow V9, which demonstrate effective real-time emotion detection with yellow 9. And the fourth one published by Kurzesli and all on 2024, and the technique are used in CNN and CLCM. Here the limitation is handling complex facial variation, scalability for real-time application, and a lack of comparison with advanced deep learning model. And the fifth one written by Hussein, which was published on 2024, and the techniques used in yellow, uh, which highlighted yellow's incremental innovation and envisioned federated learning for privacy and generalization. And sixth one published by Assad, which one published on 2022, and technique used CNN. Research gap is lack of real-time efficiency, robustness, uh, and lighting variations. And the seventh one written by Soumya, which was published on 2022. Here the techniques are used in deep learning and CNN, limited exploration of real-time performance, lack of. This is my methodology. Here I have taken number of images. Then I have pre-processed the images using median filtering technique. Then extract image, face detection, feature extraction using yellow V11, emotion detection, and the performance are measured in accuracy, F1 score, and sensitivity. Here I am collected data which contain 1200 images, uh, which are divided in seven classes: happy, sad, disgust, surprise, angry, fear, and natural. Data pre-processing, here I have used median filtering approach for data pre-processing, which uh, this is techniques play a crucial role in enhancing the quality of images just by effectively reducing noise, which is essential for accurate facial emotion recognition. Noise, if the edges are blurred or low resolution, then it reduces the noise. And handling salt pepper noise, due to some errors, their black and white pixel are appeared in exam. It also reduces that black and white pixels, which is called handling salt pepper noise. Feature extraction, the feature extracted here, which features are extracted, these are facial landmarks, Euclidean distance, angle and slopes, facial symmetric analysis. Facial landmarks are the key points of fish, which is eyes, nose, and mouth, and Euclidean distance are distance between mouth to eye. Angles and slopes are for eyebrow, example, eyebrow tilt, or angles, mouth open. And the for feature extraction, I have used yellow V11. Yellow V11, which stands for You Only Look Once series, which introduced significant enhancement in feature extraction, crucial for tasks like facial emotion recognition. Its architecture comprises of three primary components: the backbone, neck, and head. Backbone is mainly used for feature extraction. It used advanced deep convolution network for robust feature extraction. Also, it uses a transformer-based module which is called swim transform to enhance spatial awareness and improve long-range dependencies. Additionally, it incorporates cross-stage partial network to optimize gradient flow, reduce computational cost, and improve learning efficiency. Then NAIC, it is mainly used for feature aggregation. The NAIC section utilize path aggregation network to enhance scale feature fusion, ensuring better object representation. It also includes feature pyramid network to capture special details at different resolutions. Also, it uses dynamic convolution or in to introduce to adjust. This here, that's my result table and the graphical representation of result. I have taken data by 80% and 20% by training and testing, and the accuracy is 95%, sensitivity 83.42%, specificity is 83.48%, F1 score is 83.50%. This is my graph recall confidence graph, precision recall graph, and F1 confidence graph. Here, first recall confidence curve, which shows the classification result, recall, recall and confidence, and the blue line shows the all classes. Precision recall curve. And the F1 confidence curve. This model, I have compared models, my model with yellow 5, yellow 8, and yellow 9, and I found that my model have the best accuracy and the precision recall and F1 score. And this is graphical representation of comparison graph. And that's my output images. Here showing the emotions are in boxes. The based emotion, which are showing the exact emotion, which confidence value is 1.0, and here which shows 0.4 confidence value. The emotion are not accurate, and the which showing the base confidence value, the emotions are accurate. This is my conclusion. I will conclude that in case of facial emotion recognition using yellow V1 showing accuracy of 95%, the model achieves high sensitivity and specificity, which is 83.42% and 83.48%, ensuring a balanced detection of various facial emotions. Additionally, the F1 score 83.50, which highlights the model efficiency, is maintaining a good trade-off between precision and recall. Then, given the result, yellow V1 proves that the most effective model for facial emotion recognition, outperforming previous yellow version. Its high accuracy and robust feature extraction capabilities make it well suited for real-time application for future work. Improvements will focus on extending the model for real-time facial emotion detecting using live images. Additionally, IoT devices will be integrated to collect and process facial expression data, enhancing real-time analysis and expanding its practical application.
Just 1 minute interruption. Paper ID 70, 80, 83, 105, 106, 155. Please raise your hand. Let us go to 14th floor. Your presentation will be there in 14th floor. I will accompany with you. Please come.
Okay, Rajesh Minda. One question I would like to ask. So why you have given the title is bio-inspired? What's the significance of this here? You have used that yellow 11 V11 model for that, for facial recognition. What is the significance of that bio-inspired here?
So bio-inspired here I have used equilibrium optimization
Mm-hmm. I could not hear you.
with equilibrium optimizer, which is an algorithm, bio-inspired algorithm, which helps in hyper parameter tuning processes. Here,
So what is that algorithm?
equilibrium optimization.
Equilibrium optimization is a bio-inspired algorithm.
Yes, equilibrium optimizer algorithm is a bio-inspired algorithm.
Actually, equilibrium it's a optimization, that is a physics-based optimization algorithm. It's not a bio-inspired. Bio-inspired means it's related to the biological insects or animals
Genetic
related to that.
algorithm.
It's not bio-inspired. Equilibrium algorithm is. It's a physics-based subcomputing approach or algorithm. Evolutionary algorithm you can say, but it's not a bio-inspired algorithm. Okay, thank you.
Operate. Remote thing. Good morning, everyone. I'm going to present a paper named Leveraging AI for Enhanced Credit Scoring in Financial Services. Authors Chandan Kumar Barik, Barsha Panda, Assistant Professor, Dreams University. The paper is presented by Barsha Panda. So, if we are talking about financial services, the most challenging part is the credit score analysis part or the credit assessment part. Now, the credit score rating is basically the rating that is given to a borrower, whether a borrower can repay the loan, the likelihood of the borrower who can repay a loan or not. So that is a very challenging part, and the conventional methods are not enough. So the conventional method generally uses scant information, which is not sufficient, and it provides inaccuracy. So in our paper, basically, we are going to explore how artificial intelligence and advanced machine learning is reshaping the financial risk management using machine learning and deep learning, which uses vast data set to do predictive risk analysis. So the traditional, if you're talking about the paper, so we have collected few papers, means we are going to use the major trends or the key contributions out of 50 research papers. We have considered few. Here we are basically talking about comparing the traditional methods or conventional methods. That is basically a FICO and Vantage score. Now this FICO is a very old method and widest used method. It is developed in California by Fair Isaac Corporation in 1989, and Vantage is the alternative of it. So basically, it focuses on the limited financial history, that is the past data like the credit utilization and length of credit history, payment history, all these things. Now, the credit worthiness or the credit score is calculated based on these factors, which are not sufficient at all. So artificial intelligence has revolutionized it, and it uses some additional data sets or additional data from social media, transaction histories, online behavior, the spending habits, everything is considered here to make it better. So as per Khandani in 2010 and Siddiqui, these artificial intelligence methods, what are the how the data sets can be utilized here? All these methods are discussed in these papers. So yes, sir. Yes. So in the methodology part, basically we are discussing about first, we have used a model that resembles the Prisma framework. In this model, first we are going to start it, then data collection is done where sentiment data analysis is done. In sentiment, the textual description of the data for opinion trends are analyzed. Then political situation data is analyzed, the government website data like the news articles and all. Then Yahoo Finance data, from where we have collected the data from, we can say the stock data, the history, price trends and all. Then the second step, it considers the filtering of data. That is the feature extraction, where we have extracted useful data. Then feature engineering and pre-processing, where the data is pre-processed or clean data is mentioned. Then the final data set out of it. Then the Pearson correlation calculation is done. That is the comparison of numerical techniques. That is, we are comparing two techniques like the sentiment score and the price. We are comparing here to get the outcome. Then after this, the final data set we are getting, and we are using making use of the machine learning algorithm. We are using training algorithm and testing machine learning algorithm. In training, basically the model is trained, and testing how the model perform, how accurately the model perform, that is mentioned. Then finally the result is analyzed and the end. So in the result and discussion, here we have increased accuracy in the risk assessment. So using AI, we are getting good accurate data. Then faster decision making and fairer. Fairer means as we are doing analysis on it, we are getting good, means the fine data, we can say. Then fraud detection, real-time fraud detection means continuously it is working on that, continuously it is doing the analysis, and instant risk assessment is done. Then pattern recognition based on the patterns and trends in the fraudulent activities. The patterns are studied, the trends are mentioned. Then we have the market risk analysis factors, like we can predict the stock trends, whether it is going high or low. Then asset performance using sentiment analysis. Then AI-driven portfolio optimization for risk management. So in the conclusion, basically, we are talking about how we are achieving accuracy, efficiency, and fairness in a data. So we are using here, we can further we can talk about how we can use this AI with blockchain and Internet of Things. So in blockchain, we can achieve secure data and IoT real-time security in fraud assessment and all. Then explainable AI, where clear, understandable, and interpretable AI we are talking about. It is giving us the way in which we can comply with the financial regulations and ethical AI. That's it. So this is a reference, and thank you. Any questions?
Is it the survey you have conducted, or you have done some work on this?
No, sir. Actually, it is a survey only from 50 research papers. We have collected how we can use this, what methodology we can use. We have just proposed it.
This is not proposition, this is a summary. So you should have taken a analysis on that. That means
Yes,
which
the
method
further
have
we will-
used and what
yes.
are the accuracy, or what are the parameters? They might have taken some parameters for evaluating their performances. So you
Okay, sir.
might have recorded that particular articles that you have collected, and what are the findings you must have represented in a summary sheet. You could have a better way of presentation.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Good morning, everyone. Respected sirs and session chairs. Actually, high efficiency optical polarizer using silicon-based 2D device for photonic integrated circuits. This is my paper topics. Actually, when we see that high-speed computations or any type of optical connectivity or communications, if we see in the nowadays or in the future, it requires an high-speed data. Now, for that purpose, this present paper proposes an optical polarizer based on the silicon-based 2D photonic crystal structure, which demonstrate high efficiency and compatibility with photonic integrated circuit. The structure effectively polarizes the integrated circuits. Integrated circuits, optical integrated circuits, the structure effectively polarized in 1500 nanometer to 1720 nanometer range. Now we see this, how they can. Here, photonic integrated circuits, this is my introduction part, are emerging as a crucial technology in the development of high-speed optical communication systems, optical computing, and various signal processing applications. Here, PICs, that is photonic integrated circuits, use photon to manipulate and transmit information, offering significant advantages in terms of speed, bandwidth, and power efficiency. A fundamental components of many photonic integrated circuits is the optical polarizer, a device that ensures the correct polarization state of light within the circuit, which is essential for the optimal functioning of various optical devices such as modulators, switches, and filters. The need for efficient polarization control with PICs has led to increased interest in the development of high-performance optical polarizers that are compatible with the silicon-based platforms commonly used in photonic integrated circuit fabrications. Silicon photonics, the technology of using silicon as an optical medium, has gained significant attention due to its compatibility with existing complementary metal oxide semiconductor CMOS fabrication process, scalability, and cost effectiveness. Silicon-based devices enable the integration of optical and electronic components on the same chip, making them ideal for mass production. Among these silicon-based devices, two-dimensional materials have recently attracted attention for their potential to enhance optical device performance due to their unique optical and electrical properties. The combination of silicon and 2D materials offers new possibilities for the development of highly efficient, compact, and tunable optical components, including optical polarizers. Here is our proposed silicon-based 2D photonic structures. You see this. This image shows the 2D photonic structure with a central defect is an array of air-filled holes. It consists of a metamaterials or photonic crystals with a square lattice of circular air holes embedded in a dielectric material arranged periodically with a lattice constant AAA, that is the distance between two neighboring holes, and the radius of AAA. The red square at the center represents a defect that basically disrupt the periodicity of the structure. Actually, this square, you see this defect at the center, the red square, you see this defect acts as a trap for light, enabling the localization of specific wavelengths that would otherwise not propagate through the crystal. Such structures are often used to create cavities or resonators in optical sensors, filter, or lasers. The arrow pointing to the defect emphasizes the absence of an air hole at the center, where resonance occurs, enhancing sensitivity for application like optical sensing.
Please go to your model.
Yes.
You would able to understand the fundamental
Actually,
concept.
by modifying the size, radius, or lattice of the ear holes, the structure can be tuned to detect changes in the refractive index caused by nearby substances such as cancer cells or any type of, suppose, any affected cells or calculus in your teeth. You just place these substances. So, the defect strengthens the interactions between light and surrounding materials, making the structure highly suitable for biosensing, aligning with our research on optical sensor, and serving as a promising component for cancer detection through light-matter interaction. The operational mechanism behind this intriguing outcome is governed by the interactions between the input signal and the physical structure. These interactions can be described mathematically using the solution of a Helmholtz wave equation, complemented by numerical computations.
Please go ahead to the model. Your model, proposed model. You don't have any model?
No, actually, we did.
It's a survey type
This
of
is the
model.
model. This is the proposed silicon-based 2D photonic structure.
This is the background. That means your proposed work, right?
Yes, proposed work.
Or whatever work has been done in this.
Actually,
particular-
we see here, we use 1500 nanometer to 772 nanometer range of wave. Here, the input wavelength spectrum is divided into distinct ranges. Here, the input bandwidth range is 5 terahertz to 3.4 terahertz. In 5 terahertz, we get 1500 for 1500 nanometer. We in a simple earbone, if we get a samples,
You go to figure number 2A to 2H. Where is that? Figure 2A to 2H. This is 2B. Where is 2A?
this 2A
Achha,
is
2A is the okay, fine.
yes 2A,
2A nahi. 1A,
1A, 1B,
1B. Where is 2A? 2A is not there.
Missing.
2A is not there. Right? 2B. Where is 2H?
Oh, well, it is 1500. It is missing. 1500 to 1534 nanometer.
Is there any 2GH?
Yes, yes.
Okay, fine. So what are the significance of
Actually,
these results?
what we get here, the visuals results of these figures of 2, that is 2A to 2H, highlights the directional behavior of the output electric field, which consistently follows the diagonal axis across all figures, indicating the effective polarization achieved by the proposed design. Notably, no electric field is observed outside the designated diagonal path, emphasizing the structure potential as a polarizing element. The base material used for the photonic crystal structure is silicon, which contributes to the design's overall performance. Although the overall directional pattern of polarization remains consistent, the electric field magnitude vary with different
Okay, kindly
input
go
signals.
to figure 2B. Plot 2B. Okay, 2H. What is the significance of this plot? What it represent?
Actually, electric field, one side we see what is the response in the electric field, as well the magnetic wave. Actually, when wave is propagated, lower electric field zones are there.
Both
and
the diagrams are okay. Fine. So you have varied the
actually
input
varied
signal.
the
Input signal.
signals. 1500 actually from here you see 1500 to 1534, then 1534 to 68, just like this.
Okay. So what is the observation from this variations? in
From these
signals?
variations, what you see here, you see this. The following the confirmation of the photonic structure polarizing function for the analysis involves the calculation of optical bandwidth for both input and output signals. This figure 3 represents the comparative optical bandwidth directives from these calculations, solidifying the efficiency of the proposed structure for polarizer applications. Here we see two lines, one is red and a blue
That means only you have varied the signal
signal.
and observed the polarization.
Yes, polarization.
So which method you have used for that?
We use in the MATLAB.
No. MATLAB is a tool.
Yes.
But any methodology have been proposed in this particular?
No, we check that using this technique, just if there is an air holes in from this, we
No such method was earlier in the literature. You have
no,
proposed.
only just introduce this.
Oh, that is your
Yes,
innovation.
yes.
There is no such techniques.
Different techniques they use in our reference. You see,
So why don't you make a comparison of this? In order
actually in high frequency signals, if we passes through this, here you see that in 5 megahertz, 5 terahertz to 3.4 terahertz signal, if we passes through this 1500 nanometer to 772 nanometer, the output bandwidth ranges from 85,000 terahertz.
in your model.
Yes.
So my question is that why don't you have make a comparison with other existing methods, whatever parameters you have assumed or you have considered for your simulation, that must be taken care for other existing methods. So in order to find the efficiency of your proposed method,
Here
it should have been
the external first things is the frequency range. First things we see that the frequency range 85,000 terahertz at 1500 nanometer we get to
Okay, do you have any plan to fabricate this?
Yes, we have to plan to fabricate this
Where you have planned to fabricate?
in Calcutta, sir.
Calcutta.
Yes. IC center, you know, the Jadavpur University IC center. We are working with this.
Jadavpur University IC Center does not have this much nanometer devices to. You cannot fabricate there.
Optical Society of India developed a center, so totally for.
Do you have plan for that?
Yes, we are already we published two journal paper on this.
Okay.
Optical IC.
Okay. Thank you.
This is the conclusion. This paper presents the design and implementation of high efficiency optical polarizer using a silicon base.
Thank you.
Oh, thank you, sir.
Next presenter, please.
Paper ID 52. Paper ID 164. Then paper ID 28. 164 is present. Okay, please.
Yeah. 164. Presenter 164. Yes, come. Why you are delaying?
Okay, good morning all. So my name is Avinash Kumar Pala. So I am from NIST University, a PhD scholar. And here I am presenting the title of the paper is Deep Learning Based Face Recognition System with Modified MTCNN and FaceNet. And these are authors of the paper. So introduction to the system. So this is a face recognition model, a hybrid model of using MTCNN, a modified MTCNN and FaceNet. So mainly what is the use of this face recognition system? So face recognition can be used for this biometric technology for human identification and authentication. Mainly we are the main application for our is for criminal detection by using this face recognition. So also its application is attendance system, security, payment, access control. So in this system, this face recognition system, various challenges are also there. So that is your in the data set or the images, the variation in poses, resolution and occlusions. So this proposed approach, so here it is an integrated model of MTCN and FaceNet. And here we are achieving 94.4% accuracy on LFW dataset. So in background, the basic face recognition process. So it is having mainly 3 steps, that is your face detection, feature extraction and face recognition and a database. So mainly face detection means locating faces in the image or video frames. So next is feature extraction, means identifying unique facial characteristics. Then verification or face recognition is comparing extracted features from the database. So in that figure, it is mentioned that basic how a model face recognition model have these minimum these parts. So here key technology used, that is a MTCNN is a cascaded architecture of 3 networks, that is a PNet, RNet, ONet, and a FaceNet transform faces into unique 120 dimensional embeddings, and a pipeline that is your detection to embedding then recognition via similarity measures. So here the literature survey. So we are taking 3 papers for the reference. So the 3 papers, first one is also they are using same MTCN and FastNet for the LFW dataset, and they are getting 92.86 accuracy. But the limitation is their high model size and high computational requirements are there. And in second also they are using same MTCNN with triplet loss, and they are using LFW dataset and getting the accuracy is 86%. And third one is that is your face detection using face mesh technology. So they are getting 94.23 accuracy on 1700 images. So in this third paper, they are using LFW dataset. With that, they are also adding some of their images on that dataset, and they are taking that for their test. So here the challenges in face recognition mainly the high variation in facial poses and angles, inconsistent resolution and image quality, occlusions, next lighting and environmental variations, then computational efficiency is required. So these are main challenges in a face recognition system. So we need to improve these things in a system to make it more efficient. So research gap need to more robust detection under challenging condition. Means suppose a different type of lighting and different type of face size, resolution type, then balance between accuracy and computational efficiency, integration of spatial and semantic facial features. So here in methodology, the data preparation. So we are taking 3 data sets for our test. So LFW is one that is having 13,000 images of 5749 individuals. Another is your Hollywood celebrity dataset. So it is having 1800 images of 18 celebrities. And Indian politician dataset having 11,200 images of 112 politician or peoples. So in pre-processing, we face alignment using MTCN. So it is done by the model to face alignment using MTCN, then pixel normalization, and we are using data augmentation technique, that is to make the dataset more useful, that rotation, flipping, zooming, these things are done to the dataset. So this is the overall face recognition pipeline for this model. So we are taking input image, that is 48 into 48 into 3. Then we prepare some pre-processing, that normalization and data augmentation. Then mainly we are using MTCNN for detection, that is having 3 cascaded networks, that is your PNet, RNet, ORNet. And that features are fed to the FastNet, that is a FastNet having embedded network and triplet loss, and a post processing unit, feature fusion, attention layer, similarity comparison, then the recognition result. So these are the main idea or steps of that face recognition system. So in the methodology, mainly what we change in that MTCN. So this is the model of MTCNN. So we change. So in the PNet or proposal network, so we are adding a convolutional layer. So in that additional convolution layer is there in that PNet. Next, refinement network or RNet, we are using a block, that is a squeeze and excitation block. So in this second block, we are adding a block, that is your squeeze and excitation. In the output ONet, where dilated convolutions layer is added, so that it will make more efficient. Next, in the FastNet feature extraction, so we are using ResNet 50 backbone, that is replacing the original inception, and a 120 dimensional embedding space and training via triplet loss function. So this is the block diagram for that FastNet training pipeline. So we are adding some ResNet 50 block backbone, and that embedding generations to the second block and loss computation. That for that we are using triplet loss and that weight update. So this is the training pipeline. So the total two models are trained. So this is the procedure. The procedure, stage 1, stage 2, these are the procedure. So how we are performing this model or preparing this model and performing the what experiment or we are getting the results. So these are the procedure only. So it is written in stepwise. So this is the result. The result of three data sets were used, that LFW, Hollywood and Indian politician data sets. So one is your accuracy versus epochs, and there is your loss versus epochs. So it is also represented here in model performance. The LFW data set, we are getting 94.4 accuracy, and Hollywood celebrity, we are getting 93.9% accuracy, and Indian politician data set, we are getting 94.3 accuracy. And also the same model is compared with the literature review, the three papers we are taking in our literature review. So on that literature review, that paper, the first review 1, 2, 3, they are getting the accuracy respectively 92, the 92.86, 96, 86, and 94.23. In our proposed model, we are getting 94.4 accuracy for that LFW dataset. Then the training details dataset split, it is 80% to 20%. That for training we are used 80%, 20% is for testing. We are taking 100 epochs. Learning rate is your cyclically between 0.0001 and 0.001, and triplet loss convergence minimum of 0.21 on LFW. So main key observations here. So the robust to occlusion and varying lighting condition, and effective across diverse demographics, multitask loss optimization for both detection and recognition, the bilinear pooling and multi-head attention mechanism for improved feature utilization, triplet loss created discriminative embeddics. Then the limitations are model complexity challenges for resource constrained environment, need for further optimization technique, that is quantization. So in that summary word, we are getting the accuracies that on LFW, that is your 94.4. Then we are using bilinear pooling, multi-head attention, advanced data augmentation. Then we are using triplet loss, adaptive threshold, ensure precise feature embeddings, and improve the baseline methods. So future work is explore model optimization for resource constrained environment, scale for larger data set and real world application, and integrate privacy preserving mechanism, improve real time processing efficiency.
Okay. MTCNN is your proposed model.
Yes, yes.
How many layers you have considered?
Yes, sir.
How many layers you have considered this in this model?
How many layers we consider? So in the model, we only change some in three networks are there. On that network, we are adding some convolution layers.
MTCNN is your own proposition.
No. Here we are in that MTCNN model, we change some layers.
Okay. So how many layers you have added?
One convolution in that first network. Then in each, but in each,
You will keep on answering. No issue.
okay. So here in the first network, we are in that PNet, we are adding a convolution layer. So in the second, that RNet, we are using a that SE block, that is squeeze and excitation block. And in the output ONet, we are used a dilated convolutions. So these blocks are we are modifying some layers and keep testing. So in this condition, we are getting some good result.
What parameters you have evaluated?
Okay, parameter.
Performance parameters.
Okay, that accuracy and
Do you have any slide simulation results? Okay, what it represents? Epochs? Loss.
Accuracy and loss.
Accuracy and loss you have already comparison. Okay. So what is the results you are obtaining? That means whenever the loss is decreasing, accuracy is increasing.
Yes.
Right. Okay. So you have considered 100 epochs.
Hmm.
Okay. Next slide. Okay.
Okay, in PNet, you have added one convolution layer. In modified other network like AC block, you have added. What is that AC block?
That squeeze and excitation block
What is that? Squeeze and excitation block means?
means it will what?
What that blocks actually contains? Is it a CNN layer?
Yes, yes,
Hmm?
yes. So it will modify, maybe reduce the dimension.
Okay, it will help you to reduce the dimension. Okay. So that is squeeze is fine. It will help
Yes.
you to reduce the dimension. What is excitation then? Why you are calling it as squeeze and excitation block? Okay. Sure. Okay. Okay. Thank you.
Good afternoon, everyone. A very warm welcome to the second International Conference on Cutting Edge Technology in Computing, Communication, and Intelligence, ICC-TCCI 2025. It is an honor to have you all here with us today. It is with great pleasure and humility that I stand before you today at this esteemed international conference. My name is Priyanka Behera, and I am deeply honored to have the opportunity to address such an esteemed gathering of brilliant minds and innovators from across the globe. Institute of Management and Information Technology, Cuttack, was established in 1962 by Government of Odisha as College of Accountancy and Management Studies, CAMS Cuttack. This conference represents a unique opportunity for us to delve into the latest advancements in technology and explore the frontiers of computing, communication, and intelligence. With the participation of experts and innovators from around the world, we are set to embark on a journey of knowledge exchange and collaboration that promises to save the future of these critical fields. Now, I would like to welcome Professor Bibhudatta Sahu, NIT Raulkela, whose guidance as General Chair has been instrumental in our journey. He has provided visionary leadership, driving the conference forward with his expertise and enthusiasm. Sir, we look forward to your valuable perspectives. We are honored to welcome to Professor Srinivas Sethi, IGIT Sarang, whose dedication as program chair has saved the success of this conference. Sir, your insights are easily awaited. A very warm welcome to Professor Manas Ranjan Kabat, Principal IMIT, Sir, whose leadership at IMIT Qatar continues to inspire us all. Under the able guidance of our organizing chair, Professor Kabat, the conference has taken shape, promising a memorable and enriching experience for all the participants. Sir, your presence here today is truly an honor. A very warm welcome to our convener, Dr. Icctcci, Head of the Department, Computer Science and Engineering, IMIT Qatar, who has worked tirelessly to bring together the various elements of the conference, ensuring a seamless execution. Engineer Kalibada Tripathi, after his BTech in Information Technology in 2005 from Bizu Patnaik University of Technology, Raulkela, served for various IT companies like Tata Consultancy Services, Tech Mahindra, Jawan, and Access. Now, he is working as the data scientist in Rakuten, Tokyo, Japan. Engineer Tripathi passionately works for strengthening Japan-India relationship, for which he organized many philanthropic events like Satsang of Sri Sri Thakur Anukul Chandra and established peace and harmony among Japanese people and global Indians. He is the founder of Kalinga Japan Forum, secretary of Satsang Japan, and CEO of Moksha.com. He is passionately working towards making Odisha a $1 trillion economy by organizing multiple national and international events along with ministers and many dignitaries. He promoted Indo-Japan culture and established Supreme Lord Jagannath by digital media like Osaka TV. Thank you. A very warm welcome to Engineer Kalipada Tripathi to the event today. Thank you.
Namaskar. One interruption, please. Can you please maximize the screen? Please make it full screen so that it will be visible. It is visible, but it should be full screen. Please, please go for the presentation mode. F5. Yes.
Thank you so much, sir, for sharing your expertise and insights with us today.
Any queries from audience side? Any queries? Any question? No? Then thank you. Please proceed. Thank you, Kalipada Tripathi, for your valuable time sharing with us. Namaskar.
So now, very warm welcome to Dr. Ning Zukanin Khizi. Dr. Ning Zukanin Khizir, PhD, is a certified MBOT professional technologist and associate professor in the Faculty of Creative Technology and Heritage, and deputy director of the University Malaysia Kelantan UMK International. His research interests include advanced methods for educational technology, multimedia, and visual communication interactions in Islamic perspectives, software engineering, cyber security risk, information security risk management, entrepreneurial leadership, business and education computing, e-commerce, and creative commuting related projects. As a founder of Creativation Lab UMK, University Malaysia Kelantan, he leads several high-impact entrepreneurship innovation projects and consultancy focuses on creative innovation and digital technology. Before taking an academic position, he had more than 20 years of experience in ICT integration, entrepreneurship, projects for government agencies, private companies, and higher education. His niche area, research work, focuses on creative innovation and digital technology. He has received various recognitions and awards in research and innovation competitions at the national and international levels. He was granted 10 IP for various innovations and inventions from technology research to innovative entrepreneurship education models, and he has written more than 70 journal articles, case studies, conference proceedings, and other writings in the areas of applied digital technology, creative computing, entrepreneurship, education, innovation, and cybersecurity. He is a member of the MBA Advisory Board, UNIKL, the DBA Advisory Board, MIU, Master Trainer of Computational Thinking, MDEC, Professional Software Tester, MSTB, TTAC Auditor, and the member of the Panel of Assessment and Professional Technologist, MBOT. He received a top 2018 Outstanding Entrepreneurship Mentor Award from the Ministry of Higher Education, Malaysia. He is a member of the Technology Advisory Board for Broadcast, a digital financial merchant payment gateway online solution on web IMPAN STN BST. A very warm welcome to Dr. Nick Zulkarnain Khizi.
I believe there is no questions from the audience. Thank you for the informative.
Thank you so much, sir, for sharing your expertise and insights with us today. Thank you so much, sir.
Good afternoon, all of you. Uh, Now we are at the end of the first half of this conference. Now I like to request all the invitees, session chairs, and all the delegates to have lunch in the fifth floor. We have arranged the lunch in the fifth floor. So let us go to the fifth floor to have the lunch. All the paper presenters, please be here so that we can have the photo session. Those who have not taken the photo in our camera in the first half, they have not taken the photo. Please come here, take your photo here. After 2 minutes, we'll go to the lunch. So the paper presenters who have presented in the first session, I think they have not given their photo here. Please come here, you take your photo. Our professional cameraman is here, he will be taking your photo. Please. The paper presenters of first session, please come here. If the photo is not taken, I will be taking the photo. So it will be for you as well as for us. Yes, with this background, we will be taking the photo individually. Okay. For the initial paper presenters and those who have presented the paper in the 14th floor, please come individually. Let us take the photo here, please. Please take one photo. It has. Please individually come here and take the photo, please. Salah tak?
Excited. Yeah.
ତମ ସେତେବେଳେ କହୁଛି ଉଠା ଉଠାଉ ନା
ହେଇଛି ତ
ଉଠେଇଲୁ
ଟିକେ ରହ
ହାତ ମାରନ୍ତୁ
ऊपर हाइट करी सॉरी
सत्य सर
हमको फोटो शेयर करके व्यस्त हूं नहीं तो ग्रुप रे दे देबी व्हाट्सएप ग्रुप रे पके देबी सब फोटो गूगल ड्राइव रे पके देबी अच्छा आई एम बस हां के साइड है